We will now see a basic implementation of the facade design pattern. In this project, I'm going to create a couple of classes. We'll call this class A, and it will simply contain a method call A. I'm not going to implement any functionality in this method. Let's add a few more classes. This is class B, and we'll add a method call B. We'll add one more. So these are the classes that the client has to use, and these are part of some system. I'm going to add a class here called as client. The reason for creating a class is that it will show up as a separate class in the class diagram. So the client needs to use the functionalities of the different classes. So we will add the pointers of these classes. We will initialize these in the constructor. So there we are, we have initialized them, and we should also write a destructor in which we can delete the allocated memory. Ideally, we should use smart pointers, but in this basic example, we'll just use the raw pointers. Then in invoke, we will call the methods of these classes. That's it. And let's create instance of the client class. And we will call this method invoke. If we run this, there won't be any output because we have not implemented any of the methods in any of these classes. Let's see the class diagram. That will give us an idea of how the client uses these classes, and we will show these pointers as an association. Let's just interchange the positions of these classes. All right, this is what we have. Assume that the interfaces of these components in the system are complex to use. So that is one thing. The second thing is that you can see the dependencies of the client on these classes. So the client is tightly coupled with these classes. If any of these classes change, then the client may also have to change. So we want to create a layer over here through which the client will access the functionality of these classes. That layer will serve two purposes. One is the layer will convert the complex interfaces of the classes in the system to a simple interface. And secondly, it will also reduce the coupling between the client and these classes. So let's go ahead and create the facade. We will add a class called as façade. And the façade class will now hold the pointers of these classes. And then in the façade, we'll add the constructor and a destructor. Now façade will instantiate these classes and will also be responsible for deleting these instances. And in use, we will simply invoke the methods of the classes A, B, and C. This is it. We're done. Now the client will only have a reference of facade. So here we'll create instance of the facade and then delete the instance here. And in invoke, the client will simply invoke the method use. Let's build this. Let's look at the clauses through the class diagram. Here, clauses A, B, and C are part of some system. So we'll call this subsystem, and these classes are the subsystem classes. Now the client does not directly use these classes. Instead, we have created a facade here. What does a facade do? It converts the complex interface of the subsystem classes into a simple interface. Because of that, the coupling between the client and these subsystem classes is reduced. This way, even if the subsystem classes change, the client will not be affected. So the purpose of the facade is to simply convert the complex interface into a simple interface. That's all for now. In the next lecture, I will show you a real-life implementation of the facade pattern. See you there.